All right, so in Getting Ready 20, this first part we're going to look at completing, so filling in some arithmetic and geometric sequences. What we called this previously was each of these boxes that we're going to fill in is actually an arithmetic mean or a geometric mean. Okay, so just to refresh your memory, an arithmetic sequence must always add and a geometric must multiply. All right, so we're going to have to do two totally separate problems. As you show your work, make sure you have an equation for each, for the arithmetic and for the geometric. Okay, so if arithmetic is adding, to get from 4 to 324, we must have added something once, twice, 3 times, 4 times. So each one of those, I had to have added the exact same value. I'm calling it m. You can call it whatever variable you want. So that means 4 plus, there were 4 m's added, so 4 times m equals 324. Leaving us with just this linear equation to solve. Subtract 4 from both sides. So 4m is equal to 320. Divide both sides by 4. M is equal to 80. Telling me then that my constant rate of change is 80. So let's try that out. 4 plus 80 is 84. 84 plus 80 is 164. Plus another 80 is 244. Plus another 80 is 324. All right, now we have to completely start a brand new problem for the geometric. Although we set it up much the same way, with the exception being that geometric we multiply. So once, twice, 3 times, 4 times, but now we are multiplying by what we call a common ratio. So I'll use R, the common ratio 4 times. So that means we started out with 4, we multiplied by R, then another R, then another R, then another R. So the short way to write that is R to the 4th is equal to 324. So as we solve this, we divide both sides by 4. R to the 4th is 81. And now, in order to undo, to the inverse of raising something to the 4th power is to take the 4th root of both sides. So remember, whenever this is an even exponent, as 4 is, then we always end up with 2 possibilities. So R can either be positive or negative 3. Right? So you don't have to do or consider both as you fill out your table. You could use either one. I will do both. So I'm going to split these boxes up. If we use positive 3 as our common ratio, 4 times 3 is 12, times 3 is 36, times 3 is 108, and times 3 is 324. If we instead use negative 3, then this is a negative 12. This is still 36. This is negative 108. And then we're back to 324. Okay. Number 2, for our arithmetic, again, we're adding that same value 1, 2, 3, 4 times. I believe all of these tables have 3 blanks in the middle, so you are always adding or multiplying by your common difference, common ratio 4 times. So 3 plus 4m equals 48. Subtract 3 on both sides. So 4m equals 45. Divide both sides by 4. Now, 4 does not too nicely, go into 45, but it is a neat decimal, so you can use 11 and a quarter, 11.25. So if we add that here, that's 14 and a quarter. Add another 11 and a quarter, we're 25 and a half. Another 11 and a quarter is 36.75. And finally, another 11 and a quarter does get us to 48. Okay. For the geometric, we're starting with 3. We're multiplying by some unknown ratio 4 times. So R to the 4th is 48. We divide both sides by 3. R to the 4th is 16. Take the fourth root of both sides. So r is either positive or negative 2. So 3 times 2 would be 6, 6 times 2 would be 12, 12 times 2 is 24. If negative 2 is another possibility, then this one could be negative 6, this one could be negative 24. It just changes every other one. Number 3, for arithmetic, again, we're adding some common difference 4 times. So negative 6250 plus 4m is equal to negative 10. So to solve that, add 6250 to both sides. That leaves us 4m equal to 6,240. Divide both sides by 4. That would leave us m equal to 1,560. Okay, so negative 6250 adding 1,560 is negative 4690. Add another 1560, we're at negative 3130. Add another 1560, we're at negative 1570. And then the next time it brings us to negative 10. All right, for geometric, start with negative 6250, multiply by something 4 times, and then end at negative 10. Well, here, this feels a little weird, but we're dividing both sides by negative 6250. So that leaves us r to the 4th equals, negative 10 over negative 6250. Well, the negatives cancel, so we are a positive answer. If I think of this rather than a division problem as just reducing, I can divide both of those by 10, and it's positive 1 over 625. Do not round into a decimal there. I think the decimal, the decimal is 0.0016, which would be okay to use, but you do not want to round that to, say, 0.002. That would change the value. Now we take the 4th root of both sides. R is equal to, it's an even exponent, we do get 2 answers, and it's positive and negative 1/5. 1/5. So our multiplier can be 1/5 or negative 1/5. So negative 6250 times 1/5, if we're doing the positive, is negative 1250 times a positive 1/5 would be negative 250 times another positive 1/5 would be negative 50. One more time gets us negative 10. If we chose to use the negative, it just switches every other sign. This stays negative 250, this becomes positive 50, and so on. Okay. Number 4, start at negative 12, add the same value 1, 2, 3, 4 times, and get negative 0.75, which is negative 3/4. Add 12 to both sides. That's really 12.00. So 4m is equal to, that's 11 1/4. Okay. Divide both sides by 4. Now, that decimal is 2.8125, and you are certainly welcome to use that if you want to. If you just turn that into a fraction, 11 1/4 over 4, a simplified fraction without the decimal would be 45/16. Well, I'm sure nobody likes that one. As a mixed number, that's 2 and 13/16. So any of those three values are okay as your common ratio. Okay, so let's try to put this in. Negative 12 plus 2.8125, negative 9.1875, plus another 2.8125, negative 6,375, plus, one more time, gets us negative 3.5625. And just to be safe, I'm going to try to make sure when I add 2.8125, again, I'm up to negative 3/4. All right, for the geometric, negative 12 times r to the 4th equals negative 0.75. Divide both sides by negative 12. R to the 4th would be 0.0625. So the 4th root of 0.0625, that's really 1/16. So I prefer to use the 1/16. R to the 4th equals 1/16. So when I take the 4th root of both sides of the equation, I end up R could be either positive or negative 1/2. Okay. And if we do this both ways, if we use positive 1/2, we get negative 6, negative 3, negative 1.5. If we use negative 1/2, this is positive 6, stays negative 3, positive 1.5 to negative 3/4. And last one of these. So arithmetic, negative 1377 plus 1, 2, 3, 4 times. We're adding the common difference and reaching negative 17. Add 1377 to both sides. So I'm left 4m equals 1,360. Divide both sides by 4. M would be equal to 340. So negative 1377 plus 340, negative 1,037, plus another 340, negative 697, plus another 340, negative 357, and if you add it one more time, you're at negative 17. Last geometric one, negative 1377 times r to the 4th equals negative 17. So we're going to divide both sides by negative 1377, leaving us r to the 4th equals, now again, it's really, really important you do not round. This needs to be 1 over 81. I'm sorry, it'd be, we divided by negative. Yes, it's positive 1 over 81. If you tried to make that a decimal, 1 over 81 is 0.01234567. That is not something that you can use. You do not want to round that. Take the 4th root of both sides. So r can be, again, it's an even exponent, so either positive or negative 1/3. If we use positive 1/3, then I would get negative 459, and then another negative, but 153, and then negative 51, leading me to negative 17. If I use the negative 1/3, this is positive 459, stays negative 153, positive 51, and negative 17. Okay, so we're looking at either linear or exponential models in this second part of the homework. And we're going to write just the explicit equation. We do not need to make the recursive. So for explicit equations, no matter what type of function we're looking at, we need the 0th term. So if our table does not give us the 0th term, we're going to need to find that. Okay, so what do I see happening in this table? From -4 down to -11, down to -18, that is subtracting 7. So this is definitely a linear model. It has a constant rate of change, meaning my equation is going to be y equals mx plus b. Now, usually when we were looking for that 0th term, we just sort of went backwards in the pattern, 1 or 2 spaces till we landed when x was 0. I want us to try another method here, because sometimes your table might start with the 2nd or 3rd or 4th or 5th or 10th term, and you don't want to bounce all the way backwards from the 10th term to the 0th, one at a time. So here's what we do. We set up our equation in this y equals mx plus b form, where we plug in the constant rate of change, in this case -7 for m, and we pick any one point that we know. I'm just going to go ahead and pick 2, -4, since it has the smallest numbers. Since 2 is the x value, I'll replace x with 2. -4 is the y value, I'll replace this y with -4. And the only thing I don't know then in the equation is the b value, the y-intercept. But I can solve for that. So I'm left -4 equals, when I multiply -7 times 2, that's -14 plus b. Add the 14 to both sides as I'm trying to isolate the variable b. B is equal to 10. B, again, stands for my y-intercept, my 0th term. So I now know the full equation is y equals -7x plus 10. So this is how you can solve for the y-intercept using the rate of change and a single point. And which point you choose doesn't matter. Okay, number 7, I'm going from a fraction to a few integers. So how do I go from 2/5 to 2? Well, that might not be really obvious to you, so let's look ahead at it. From 2 to 10 goes up 8, but 10 to 50 does not go up 8. How about multiplying? From 2 to 10 is multiplying by 5. 10 to 50 is multiplying by 5. So would it work? Would it be true to say that 2/5 times 5 is equal to 2? 2 times 5 is 10. 5 times 1 is 5. 10 over 5 is 2. So yes, we do know that we're multiplying by 5 for that function. So this one having a common ratio means it's exponential. And my equation will take the form y equals a times b to the x. I'll go ahead, I guess, and use f of x since that's what's in the table. F of x is equal to the 0th term. Now, don't make the mistake of calling that 2/5 because it's the first one in the table. The a always stands for the y-intercept, which we have called the 0th. So the 0th term is here. The 0th term is 2. And then we're multiplying by 5. Raise that to the x power. Number 8, these numbers start negative and stay negative. So -24 goes down to -48. That's down 24. If I try subtracting another 24, that does not give me -96. So it's not arithmetic. If I try -24 times 2, I get -48. That times 2 is -96. So again, I have another exponential function. I do not have the 0th term here. So let's bounce back from the 2nd term to the 1st to the 0th. So if I reverse my pattern, instead of multiplying by 2, I divide by 2. The first term would be -12, and the one before that would be -6. So my function is f of x equals 0th term -6 times multiplier 2 to the x power. And number 9. From 81 down to 27 subtracts 54, but that does not continue down to the next two terms. So if we try multiplying, 81 times 1/3 is 27. That times 1/3 is 9, times 1/3. So again, we have exponential. We're going to write the equation f of x equals, now it's time for our 0th term. This time, all of these they occur before the 0th term. So rather than going backwards, I need to extend my pattern one more place from the negative first to the 0th. So 3 times 1/3 is 1. So in my formula, I can write the 1 there, or I can just leave that off, times multiplier to the x power. Number 10. We don't have a table here. We have a graph, so it's very easy to tell that it is linear. But what about points? So I want to try to choose points that I can absolutely positively tell exactly where they hit. So this point looks to be 3, 1, and this looks to be 6, 0. And that's really all I need. 2 points is enough to write the equation of a line. So the first thing I'll identify from those 2 points is the slope. Now with a graph, the simplest way to do slope is to count rise over run. But we can also use the formula y2 minus y1 over x2 minus x1. Again, I'll do both ways, so whichever you chose, you can verify here. So if I'm counting rise over run, I start at either point and first count the vertical change. Well, if I start here at 6, 0, in order to count my way over to 3, 1, I go up 1 and then left 1, 2, 3. So my slope is rise 1, run negative 3, or negative 1/3. Doesn't matter which number the negative is on or if it's in front of the whole fraction. If I chose to use the slope formula, then I would subtract the 2 y values, which are 1 and 0, 1 minus 0, and then in the same order subtract the y values, 3 minus 6. So 1 minus 0 is 1, 3 minus 6 is negative 3. Either way, my slope is negative 1/3. So in this method we used a couple problems ago, we cannot see the 0th term here, and I'm not going to try to make a table and count backwards to the 0th. I'm going to substitute into y equals mx plus b everything that I already know. Well, I know the slope is negative 1/3. So for m, I substitute in negative 1/3. I need to choose one of these 2 points to substitute in. It does not matter which one. If I use 3, 1, then the x value is 3, the y value is 1. Again, the only thing I don't have is the b value, so that's what I solve for. Negative 1/3 times 3 is negative 1. To solve for b, I'll add 1 to both sides, so b is equal to 2. Therefore, my equation is y equals slope times x plus y-intercept. Number 11, we can tell just at first glance that this is exponential, because we were told in the directions these graphs would either be linear or exponential, nothing else. So it's definitely not a straight line, it has to be exponential. So again, I can identify probably only 2 points here. I can see this one is 0, 1, and this one here is 1, 4. Now, only because I know that's exponential, this is enough to make the equation. If I know it had to be multiplying, right, because we already said exponential, then how do I change 1 to 4? Well, that means I multiplied by 4. My common ratio is 4. So my equation would be y equals the 0th term, I was given that one, times my common ratio, we just identified as 4 to the x